let's just wait 2 to 3 minutes so that people come online. So welcome everyone to the first day of Enter Web ML portal. So first of all, let me give you my introduction. I am Meet Soni. I am from Computer Engineering BTech third year, NIT Surat, and I have been working in the field of machine learning and deep learning, and also web development for about 1.5 year now. And yeah, so now, let me give you the session outlines, like what we are going to do in the session. So, as you know, all know that this is a 2-day session. So today is the first day, and today we will develop a machine learning model to detect COVID-19 is present or not from the X-ray images. And tomorrow we will deploy that model using Flask API, and so yeah, we can solve that model online so everyone can use that. So yeah, so let's proceed with the today's session. So today's our task is COVID detection from X-ray. So this is a major classification problem, and there are total main 3 class, as you can see from the data, and we are going to use this data only. And there are 3 classes like COVID-19, normal, and pneumonia. So we will be doing classification among these 3 classes, and we will give the output. Okay, and so means if you are tackling any machine learning or deep learning project, then there are mainly 3 steps involved. Or in machine learning and deep learning pipeline, there are mainly 3 steps, like collecting the data, and then building a model, like initial model, and optimizing it, and last is inferring the model. So first step is like data collection. So I have done that process for you guys. We are not going to go in detail, like we are not going to code how data is collected here. I have made a file here. I will set this GitHub link in the chat section, and you can all refer to the how is data prepared and how is data made for this thing. Okay, so yeah, let me just give you a brief overview how I collected the data. So for the data collection, I considered main two things, like Yeah, here this first repo, chest X-ray dataset. From this repository, I collected COVID-19 X-ray images, the X-ray images that contain COVID-19. So here there is one metadata.csv, and in this metadata.csv, the description about the image is given, like which patient is that, or which disease it has, and like this type of disease is given. And using that metadata, I have means extracted images that contains only COVID-19. So, and I have made a script for that, and you can go through this script whenever you are free. I will explain it in just 2 or 3 minutes. And second, I considered this data set on Kaggle, that is chest X-ray images. And this data set contains like two classes, like pneumonia and normal images. So the pneumonia images of pneumonia and normal images is collected from this website. I will also all the links are given in this GitHub repo. So, and at last I will just give the link of this GitHub repo, and you can go through all of that. So let me just explain how I made a script to collect that data and store it in usable format. Okay, so yeah, all the main libraries are imported, like pandas, numpy, and all that. And so, as I mentioned, I used the metadata.csv to find if the COVID-19 field. Okay, so as you can see, there are many columns like that in the data set, and from that column there is one field like uh, this finding. So from that finding, if there is COVID-19 present in that column, then only I am extracting that image. So for that I have made a script here, and I am loading the image and resizing the image in 250 x 250 pixel size, and then storing it in some folder, so that we can we don't have to do this data scraping and data manipulation task every time. We can just use this data to build a model. So I've done that, all the things, and also I have made a script for basic data augmentation, like here in the data augmentation part, I have made two scripts. Main one is to change the brightness of the image, and for the brightness, what I consider is like I have converted the image from RGB to HSV format. HSV is hue saturation value format, and then I'm increasing the value of that HSV image, and then I'm showing it. So this one data augmentation I have considered. Okay, and yeah, that is all for the data collection and data pre-processing task. Okay, so now let's start with model building. Okay, and you can, I will post this GitHub link in chat description, so you can go through this data collection script. Okay, so yeah, good. Let's proceed to data model building task. Okay, so first of all, I will use the data from this repository only, like this data. So, and I am using Google Collaboratory for creating the model. You can use the Jupyter Notebook or any other ID like VS Code or Sublime Text, any you want. But the main benefit of Collaboratory is that we are getting a free GPU provided by Google, and so yeah, it will be beneficial for us to train our model. So first of all, let's just change the runtime type to GPU, so we can utilize that. Okay, so first of all, we have to clone the repo that I have given for the data. Like, okay, so I am just cloning that website, that repo. Sorry. Okay, it is cloning. Okay, so the repo has been cloned. So Now I will just mount my Google Drive to the collaboratory so that we can store our trained model in the Google Drive. Okay, so command for that is, so it will mount the Google Drive with the collaboratory. So it's done. And for model training, we are going to utilize TensorFlow, and you can use PyTorch as well. But for the today's session, we are going to utilize TensorFlow and Keras to build a model. So now let's just do some necessary import, and I'm hoping that I include all necessary file libraries. If any remains, then we will just come upward again. Import OS, then sorry. NumPy is NP for NumPy is used for array manipulation in Python, and another one is pandas as PD. So pandas is used for mainly for data frames and database handling. Like means if any CSV file or Excel file is given, then loading and storing that Excel file, we use pandas, and also for like little data manipulation, we use pandas. So now we are going to import TensorFlow, and we are utilizing TensorFlow above version 2.0. So you can, if you are doing locally, so don't forget to install TensorFlow above version 2. Matplotlib is used for plotting graphs and plotting images. We are going to utilize it. So I'm importing it now. And also, yeah, these are some helper functions from Matplotlib that we are going to use in this session. Image grid. Okay, so sorry, and like another import is there are many libraries to import, so it will take some time. And, okay, so these are all layers. Layer is like nothing but means tensor means tensor like tensor is not nothing. Tensor is like a multi-dimensional array, and layer consists of that only. Okay, so means the main benefit of TensorFlow is that we don't have to use it from the scratch and develop it. We just have to use like these layers, Con2D or batch normalization. So yeah, we just have to import it and use it. It is the main benefit of like these frameworks like TensorFlow and Thera. So yeah, so I'm there. Okay, I guess I imported all the layers, important layers for today's session, and from okay, so and you can code along with me. So I'm moving very slow, so yeah, you can also code alongside with me, and you don't have to import any dependency in Google Collaborator. So yeah, you will be able to code alongside me. And we have to now use import optimizers. Optimizers is the main thing that will update the weights in the neural network that we are going to utilize now. And Adam is the most famous optimizer among them. So we are going to use that. And if you want to know about more these optimizers, you can refer to the course 2 of course provided by N2NG AI, and it is in the course 2. It is a 5 course series, like specialization series, and it is the thing about this optimizer is given in course 2. Learn is also another machine learning library in which many machine learning algorithms are implemented, but we are going to use only means helper functions to plot confusion metrics and classification report. That will help us in deciding if the model is working properly or not. And yeah, I guess all the imports are done. And TQDM is just means progressive bar. If you want to create, then you can import TQDM. Sorry. Mm, what is the mistake? NPR toolkits. One second. Let me just search which need to be import. I just copy. Okay, so yeah, imports are done. So now we can move forward. And okay, so let's now just see what all files are present in this path. data path. So we can now okay. So these all folders are present, and we have to import the data from these data folder. So okay, and let's just set some style for matplotlib. And okay, it will help. Okay, it will be fine. And okay, and it if this scheduled class assembly will help us if any previous model is load, then it will just remove it. Okay, so yeah, and okay, so now just means define some batch size and these parameters that we are going to utilize throughout. So let's just make it in global list. Epoch is now just I'm utilizing two epochs. Epoch is just like how many times you are going to train your model, how many iterations, like you are going to train your whole model using the data available. So it is called epoch, and so currently the training time takes a lot of time. So I'm going to just give two epochs, and for your training time, you can give more epochs and test with which epoch is giving more accuracy. Like it is one of the hyperparameter in the deep learning sense. So now we are going to import data. So data importing is rather means lengthy task, but TensorFlow has provided us a very great functions to make the task very easy. So one of that is this image data generator we are going to utilize. Just we have to give the means image data generator is will give us like if any augmentation we need, then we can do this using this image data generation. And this image data generation has one helper function that is a flow from directory. That in that we just have to give our directory path, and it will means collect all the images from that directory path, and it will just create one iterable object, and that iterable we can use that iterable object to train our model. So I'm just giving some augmentation parameters. Like augmentation is nothing but just doing some changes in image, like shifting image by some horizontally, shifting image vertically, rotating random image, changing the brightness that I mentioned in that data pre-processing file. So that all thing is object means augmentation. I'm setting these parameters like randomly. You can means change this parameter and see if it is working well for you or not. So and from whole data, we are going to split the data in 80-20. 80 for we are going to utilize it for training, and 20% data we are going to utilize for means validation purpose. Like uh, accuracy and validation data will give us the measure like our model is working as expected or not. And also we have one test data that for testing purpose. For that also let make one data generator, and in that we just have to give rescale because we don't want any other augmentation. Yeah. Okay. So sorry, spelling mistake in height. Done. Okay, so now let's just create data iterable data object. and that will be train data. And we have to give just path. So let's just create this data and train. Okay, so we have to give this path of train folder. So done. And target size we are going to give is 250 cross 250, 250 height and 250 width. And if it is doing some zooming, like if it is 750 or 750 image and it is changing it to 250, then we have to go give the interpolation, like how where to zoom or where to means have the image not change. So we are going to go with default parameter nearest, and the color mode will be RGB. So these are RGB images, and also class mode will be categorical. As there are three classes. If there are two classes, then you can utilize binary mode. And batch size is equal to batch size that we declared earlier, and seed is equal to 42. This seed is utilized that means that you and I means we get similar results every time. For that purpose, seed is used, and the subset is equal to training. Okay. So this whole code will prepare data in the batches, like batches of 32 that we declare, and store it in this train data as an iterable object, and we can iterate this train data object, and we will get the data. Okay, so we can get that. Interpolation, again a spelling mistake, sorry for that. Okay, so we found 363,600 images, and same data generator we are going to prepare for validation data. For validation data, okay, and all the parameter will remain same. Just we have to change this subset to validation. And images, and okay, and last is for test data. Test data, first of all, we have to change this path to test. Okay, this is nice, this is perfect. What else we have to shuffle? We have to do shuffle is equal to false, and for that we don't need seed. Shuffle false, as and it is not required, and no subset, like it is the whole data, so no subset is required. So test data is ready. 663 images we obtained from that. Okay, so yeah, all done. So data means data importing task is done. So we can now utilize this data to train our model. But and yeah, just before that, just see which classes are present and which index will give which class. In that, for that, just I will just write some few scripts. Indices. Okay, so this class indices uh, will give us class names, and this okay, so this, like, first of all, let's just print it. But yeah, it will give us like this dictionary, like if we by prediction we get zero index, then it will be COVID-19. One index will be normal images, and two will be pneumonia. We will get better understanding when we go for the prediction part. So okay, so let's just be it for now. Okay, so okay. And yeah, this session is only means like practical implementation, like practical model building and this stuff. So if you want to know the theoretical stuff behind this, then you can means I mentioned earlier that you can do online course like that T20.ai provided by N2NG. He teaches all these algorithms that different machine depending algorithms that we are going to utilize in today's session. So yeah, this is just a practical session for like how to train your own model. And like and this train step size is like number of iteration we have to do in one epoch. So like we have split the data in batches, so it will be a required parameter for us. And another will be validation step size. Okay, so step size is done. And as I mentioned, like we can get these X and Y data objects from the iterable train object, train data object. So we are going to use that for the visualization purpose, like what all images are there in our that train data. So now I will create one helper function that will show this image in a grid format. So let's just create that. So that we have to provide image list, then number of rows, like how many rows you want in that grid, number of columns in the grid, class names that we want to show on that in label list that we require, and show label it will be by default true. Okay, and figures fig size, like for it is necessary parameter for matplotlib figure. And let's just by default parameter set it as 10 cross 10. And another will be if so we want to save this figure, then utilize save name. So okay, let's create this. So first of all, like if image list is not a list, like here it will be numpy array, so we have to convert it into the list. So I'm like I will write that script for that. Minus one is for the last element. Last okay. Okay, so this list comprehension, I hoping that you all are some familiar with basics of Python, so that you can understand this coding format like list comprehension and all things. Because if I am going to explain these things in this session, that it will be very lengthy. This shape 0 is for means batch size. So this will give us 32, and we are going to store 32, and it is for grayscale images. Like in grayscale images, there are just two things like height and width of images. There are no third thing, channel in grayscale images. So for that, we are going to write this, and if we have to this same thing will be there. Color there is it is RGB image, so channel will be 3, and for that we are going to store all the thing. Okay, so all the rest of the code will be same. Okay. Now we are going to create one matplotlib figure. Like it is just like canvas that on that we can plot different graphs or create grid. Consider it as like canvas that you do painting on. Fixed size and frame on is equal to false. Setting up frame. And now just create. Let's just create grid. And for that we are going to use image grid. And in that we have to pass first of all our figure that canvas type of thing, and 111 is just like for subplot thing. If you are familiar with matplotlib, this is same as matplotlib subplot, and rows and calls is equal to, this is just means how many rows and columns you want in our grid. And that again the parameter will be axis pad. So how many distance you need or space you need between two images, and Sharol is equal to true. Okay, so yeah, these all parameter will create sufficient for our grid. So the grid is now created, and now just we will iterate through this x and y and plot the different images. For the minimum of it is required by, because if we the batch size is only 32, so if you give more number like 36 means end rows is 6 and end calls is 6, so 6 into 6 will be 36, but batch size is 32, so no image will be present after that. So for that we have to do that. And also we have to give batch size here. So the size will be only nothing but length of that image list. Length of image list. Okay. And let's just create plot that images on this axis. Okay, grid of I, and this answer function will display the image. It's the file, and okay. Also, we will so we will have the axis. If we want to show the labels, like then means if we consider label list, then label list will give us x and y is also like let me just show you how is y. So as you can see, the Y is like this type of array of 32 cross 3 size, and it is one hot encoded array. If you are familiar with machine learning, then it is one hot encoded. So from that we have to find the position where it is 1, and it will be the label index. And yeah, so that x is equal to 0 for that column, and set title. I mentioned earlier that we will be using class names for this purpose, and okay. And if you want to store the image, like if you have provided save name, then you want to store the image, and for that just we have to store like plt.savepic. This is so yeah, we have created type of function to show images in grid. Okay, so let's just test it if it is showing us the images or not. So this is in X images are stored, and let's just give 8 rows and 4 columns. So images are shown better, and why the labels are stored. So label is equal to true, and fixed size is equal to, let's just give 30 cross 10 fixed size, so the images are clearly visible. So yeah, let's just test it. uh, there is some error. Oh, sorry for that. It will be not type is not required here. Why I write it? Label, sorry, label list will be there. Label list of I. So yeah, as you can see, these are the first batch of training images that will go for the training purpose, and we have displayed a name and a label and image here. Okay, so visualization of data is done. Now let's just move forward from model building. If you find out, then just post it in the comment section. I will be seeing it in time to time, and I will reply it with my all the knowledge that I have. So model building. Model, we are going to utilize convolutional neural network to means get the prediction, and it will be custom convolutional neural network. There are different architectures also present, like ResNet 50, VGG 16, then Inception V3. But we are going to build convolutional network from scratch, utilizing that layer hyper functions from TensorFlow and Keras. So yeah, let's just get started. So input shape will be required. It will be 250 cross 250 plus 3 for channels. Panels is nothing but RGB. Number of classes in our case is 3. Okay, so let's just get started with model building. Mm, let's add one convolutional layer. Sorry. And for that, it will be required, first of all, we require number of filters. Filters is the thing here in convolution network that will learn to recognize pattern in the images, like if the line is present or circle is present or any other higher level features like eyes, nose. It can detect all these things. This is the filter. If there are some EC guys that are familiar with signal system, so they are also familiar with convolutional operation and these filters, everything. And we are going to utilize 3 cross 3 size filters, and padding is equal to same is for means it will not change the size of our image. It will pad the images with 0 so that the size of images does not change by this convolutional operation. And for first layer, we will be required input shape. Input shape is equal to input shape. Okay, and then we are going to add batch normalization. So if you consider good practice for model building, then it will be like first we add a convolutional layer, then we give batch normalization layer, then we give activation layer like a rally activation that we are going to utilize now. And if then you want to give dropout, then you can give the dropout there. So I will also follow this pattern here. And 32 filter space will be 3 for 3 and padding is equal to same. Okay, sorry, this is second layer. Before that we have to give activation layer. Activation is a thing like from that it will change your input that is coming from one layer to another to some another. Like if you consider value, then it will click all the negative values, and it will convert negative values to 0 and all the positive values to will remain as it is. So through that we will give non-linearization, means non-linear features in our model. Otherwise, it will be just means higher level of linear regression. And okay, so we will just now copy these things so we can utilize it. Okay, for second year, we don't want this input state. Not necessary. Okay, this is fine. And okay, now we have to give max to 2D that will reduce the size of image to half. Okay. And we are going to utilize dropout for regularization purpose. That will give some regularization effect in our model. So okay, just we can use this whole layer multiple time. Not require input shape. And we will just now increase the size of means number of filters. 64 filter we will take here. Everything will be same. Otherwise, everything will be same. Okay. And again we will increase the size of filter. So this is our 6-layer convolutional network. And okay, so done, everything is ready. And now we'll just flatten out all these things because this will be in 3-dimensional array. But for the dense layer or the prediction layer, we want it in 1D array, so we have to flatten it out. This will do all this thing. So like from this you can see that how much easy task this framework has done for us. Otherwise we have to code everything from scratch and it will be very cumbersome task. So this TensorFlow, Keras, PyTorch, this framework has made deep learning accessible to everyone. And also there is one means protocol means algorithm like propagation that will train this model. So we don't have to code that. TensorFlow will handle all this task for us. So we don't have to do that. So that we utilize these frameworks nowadays very frequently for the machine learning and deep learning. Okay. So last is our prediction layer will be there. And this is the last layer. Model will be done there. inference and activation is utilized. In last layer, we don't utilize ReLU, we utilize softmax. You can learn this about softmax if you search online or that in that course if you are doing deepening.ai, you will know about softmax. Okay, so it is done. So our model is ready. Let's just bring model.summary so you can see how our model goes, and let's just define our optimizer that will train our model. And learning rate is one hyperparameter. Like if you consider, if you know about this algorithm, then you will know what is this thing, learning rate. And model dot, we will just compile our model. Measure will be Adam, and loss will be categorical cross entropy. Loss will be there. If you're utilizing softmax activation function, then you have to use this categorical cross entropy loss function. Loss is something like the difference between predicted value and real classification value. Okay, so that will be that. And metrics will be accuracy. We will just measure accuracy. Okay, so all done. Okay, sorry, we have to go forward and import this TensorFlow. Sequential model and model. Okay, that's the model. So yeah, this is our whole model summary. Like there are total 16 million parameters. So you can think if we don't utilize GPU, then how much time it will take to train this model. You can understand this thing from we are seeing this. Now let's just define callbacks. Like if our validation loss does not increase after certain epoch, and then we will reduce this means learning rate. Learning rate is very important to train your optimize your model, because if learning rate is not proper, then you might not get better accuracy. Distance is equal to 3 after 3. If 3 continuous time it does not improve, then we will reduce by factor 0.2. Okay, so callbacks are done. What happened? Oh, sorry. We give it to it will monitor validation loss. It is by default argument, so we don't have to give that. Now let's just train the model. So one task only left is training the model. So it will be train data, will be the training data, and steps per epoch. It will be train step size, and the train step is the size like total images in training data divided by batch size. So it will be like that. So these are the total number of steps. Okay, this done, and epochs will be epoch, and other thing will be callbacks like Validation data will be val data, and last thing will be validation steps. Means okay, so there is one question from Anshu. What are non-trainable parameters? So if you consider non-trainable parameters is like if you batch normalization layer. So in batch normalization layer there is no trainable parameter. Like you have to use mean and standard deviation, and you are just normalizing the data. And in dropout layer you are just randomly not utilizing some nodes. So in that there are no trainable parameters. Like so these are all called non-trainable parameters, that it is just fixed. You don't have to train it. And another one is like max pooling 2D. It is not in that there are no trainable parameters. So these are all trainable. Other rest other like filters and kernels. These are all trainable parameter. Our bus is equal to 1, so it will just show us. I think it will done. It will be enough to train our model. So yeah, let's just train it. Yeah, as you can see, the training has started. You will be able to see that. It will take some time because the we as you can see there are 16 lakhs parameter, 1.6 million parameter. So it will take some time. So before that, so let's just make a hyper function to plot our means loss and that accuracy curve. And accuracy, everything means accuracy loss, then validation loss will be stored in this history object, and we have to just call that. Now you can understand like how much easy task this framework has done for us. And another I just utilize means two. I just given two epochs, so model will not be much optimized. You can give more epoch, and also utilize some techniques like uh, means learning rate scheduling, weight decay to increase the accuracy. Okay, and okay, so yeah, it will create a list of epochs like 1, 2, 3, 4. If you know about range function, then if you give range of 10, so it will give like 1, 2, 3, 4, 5, 6, 7, 8, 9 in that, and we are showing in that list. So we can use it as an x-axis for our plot. X value, y value will be accuracy. Color is equal to, let's just give red, and label is equal to training accuracy. Let's just do label like this, and we will just copy and change some parameters. Input that whole code. Accuracy instead of that will be validation accuracy, and color will be blue, so we can bifurcate that, and it will be now validation accuracy. Okay, and we will now just give show, so it will show us the plot. Now just sorry, and now just we will give plot the loss curve, training the loss. And this by seeing this graph, you will just know if your model is performing well. If you are getting the curve like elliptical curve, then you can understand that, and if loss is continuously decreasing, then you can understand that your model is trained very good, very well. And but if you, in between your loss is increasing, then you can say something is wrong with your training. So you have to means tune that parameters like learning rate, or means learning rate is not proper. Like you can and other hyperparameters you have to tune. Like you can say from this graphs. And also there is one feature in TensorFlow, like TensorBoard. Now, if you want to give, have the detailed analysis, then you can use the TensorBoard to like visualization purpose. And let's just give title here. Sorry, this is accuracy plot. And same will be that. So we are just going to copy it. And it will be loss. So these are two plots. As you can see, we have just utilized two epochs, so it is not some good. But if you utilize more epochs, then it will be proper like logarithmic type curve you will get. Further, the will continuously decrease over time over epoch, and accuracy will continuously increase over epoch. So if you are getting curves like that, then you can say your model is trained very well. And okay, so now let's just save this model. My drive, and okay, any name means cv1.h5. We will give this name. Okay, so it will save our model. You can then load your model for any other task as well if you want. And so yeah, you don't have to like train your model every time. You can just save like this and utilize it every time in whatever your application. And we will going to means use it tomorrow for deploying for deployment purpose. It will save means this will save means okay like structure of the means architecture as a whole and the weights of that different layers. It will store that. And now let's just means use one thing that is called transfer learning in computer vision. We utilize it more often. Like as you can see, if you are seeing this, like initially the accuracy is like 64% and 82%, and validation accuracy is very low. But if you utilize the transfer learning, so there are very large models like ResNet 50, Inception V3. These are all models that are pre-built, means built and trained on ImageNet dataset. And ImageNet is a dataset consisting of 80 different classes of real-life objects, and these networks are trained on that huge dataset. So you can think of that all the layers are means capable of like recognizing some pattern from images initially. So you don't have to like train the filters to know the patterns from the find the patterns from the images from scratch. So we utilize transfer learning a lot in this computer vision task. So let me just give you some fast demo like how you utilize that. Epoch is equal to, again we are going to utilize just here, just let's take one. So it is number of classes is 3. And first for that we have to utilize import one architecture like ResNet 50 from TensorFlow. So yeah, TensorFlow is again the implementation of ResNet 15 build. So you just can call it TensorFlow applications import ResNet 50. Okay, so we are going to utilize that, and let's just make it in the line. Okay, and let's just call this model ResNet 50 include top is equal to false, because we don't want means if we are utilizing the image data set, and in that there are 80 classes, but we don't want that classification layer, so we are utilizing include top is equal to false, where it's equals to ImageNet, and input shape is equal to 250 cross 250 cross 3. Sorry. And for model.layer, we are fine tuning this model for our purpose. So we have to give layer.trainable is equal to true for that. So it will train all the layers that are present in present 50 as well, not only the custom layers that we will be adding for classification. Okay, so actually model.output, and now we just have to add classification layer. And this is another method for building the model. Like first we initialize sequential model. Sequential is like it will connect the layers sequentially. So and this another method is like input output from one layer, you give it to the input of another layer. So these two methods are there in model building in TensorFlow. Well, okay. It's equals to 256, and activation equals to value. Kernel regularization we also utilize that, so that model does not overfit on our training data. And for that, keras of regularization dot L2 we are going to use, and it will be, and we will give regularization parameter as 0.01 as our regular, because we don't want much more regularization. So okay, this one day is done, and just we will copy it and utilize many. Before that, we will just add batch normalization and class X. Okay, and we will also utilize dropout, so we will get better regularization effect and better standardization on our classification task. So we will just copy it and do it for like more 1 and 2 times, 1 or 2 times. See, let's give 128. Okay, rest all will be same. And for last task, we don't want to give dropout, so we will use that. And last will be our classification layer, and it will be number of classes, and activation is equal to again softmax. Okay, so and let's just build the model. Input is equal to model.input, that we are going to, and output is equal to this final layer output, that will be out. This model is built. So let's just print the model summary. Okay, model dot layers will be there. Okay, yeah, give any name there. And okay, so yeah, this is a summary. As you can see here, 5.7 million parameters are there. So it will take more time than the previous model of our. So I will just train it for one epoch. So let's just define our optimizer. It will be Adam again. Learning rate is given. You can try different learning rate and see which learning rate is giving us better accuracy. And also train it for more epochs like 20, 30 epochs or even 50. Optimizer is equal to Adam. Loss is equal to things algebraical entropy. And matrix to see the accuracy. Okay, so okay, that is done, and okay, lastly remain is callbacks. Like here, not callback is not necessary because okay, you can give like one epoch is only there, so I'm not writing that code right now. You can add the callbacks here as well, and again, just remain is training the model, training data, train step size, and approximately our epoch, and validation data, validation step size, step size. Validation steps will be argumenting, and verbose is equal to 1 so that we can see what is going on. And callbacks is not given, so we need to do that. We just train our model. We started. Okay, so training has started. So you can again save that model. You have to give your path, that is objects. Save it to, we just give that name. And again, so now let's just infer what the model is trained on our test data set. So we will just infer that. Okay, so for that, let's just have this model trained. Also, we have to find like what all classes are present in test data set. It will be there, but the order might be different. So don't take like the order will be same as the print data set and just check it. It will just take one line of code. So okay, almost done training. It is just one app. We are only on one app, so I'm not expecting better accuracy from that. Yeah, it is not better accuracy. Okay, So I'm saving the model and class indices. Okay, so yeah, it is different from training indices. So we have to take care of it while inferring and drawing confusion matrix. So y prediction is equal to, it's like just first of all let's just predict it on. Okay, and means along with that, let me just show you how to load the model as well. And for that, you have to utilize this load model function of keras and given the path. So yeah, it is just simple one line of code, but all the models are loaded here. So I'm not realizing it right now. And let's just predict it on test data set, like how these means what results are giving it on test data set. Model dot predict, and we have to just do test data that the generator we have created earlier, and verbose is equal to 1, so that that progressive bar will come. So request data. Doing a lot of spelling mistake today. And let me just show you now how this y prediction is like. It's like a different probability value, like what is the confidence score of belonging to that class is given here. So we have to utilize argmax function of numpy so that we can get the index of that. And y prediction, and x is equal to 1 is for row and x is equal to 0 is for column. So we have to find means row wise. So we are utilizing x is equal to 1. And now we will just, as I mentioned, like it is different. In Trinity, the zero is for COVID-19, so we have to take care of that. So we will get means like proper confusion metrics and no links label misclassification is done. Like so, we have to take care of that label misclassification in train and test data set. It's a simple script like we will change it. If y prediction is 0, then it will change to 2 because the pneumonia is 2 in that. That is normal. So, okay, the 0 and it will be. I hope you understand why I'm doing this thing. It is I'm just doing it for the purpose of like table correction. Now we can just plot our confusion metric. All things are done. So just this is our last task to plot confusion metric, and we can conclude our session. Confusion matrix. Confusion matrix is a fancy word for like how many means like it will just represent for the given example what classes predict, and for three different like, let me just print it, and you will better understand what is confusion matrix. And for that real labels are y2 is test data dot classes, and y predicted is it will give us like yeah, this type of thing will be given. So here we can understand like every example is predicted as COVID here, but so it is, yeah, model is very wrong as it is just trained on one epoch, so it is not giving good results. So here, so if the model is working perfectly, so then all the values must be in diagonal. Like 1 is predicted as 1, 2 is predicted as 2, and 0 is predicted as 0. So if that type of result you obtain, then you can say the model is working perfectly. But here you can see it is just predicting COVID for all of the examples, so it is wrong. So I just to train it on more epoch. And the last is classification. Report, and for that target names will be normal, pneumonia, and COVID-19. And just we have classification report, and again for that we have to give real labels and true predicted labels, and also target names. Okay, so done. It will give us like all things will be given, like all the necessary things to check our model of accuracy will be given, like precision, recall, F1 score. If you are just familiar with machine learning, then you will know all these model means accuracy means checking parameters like all these. Okay, and accuracy is also given so very low, as you can see. You can increase it. Okay, so yeah, that's all for the session, and I want to give you one challenge or say task for the today, and your task is like you have to means train the model, means change, use different architectures like ResNet, I mentioned Inception, MobileNet, Exception. There are different architectures available. So utilize that architecture and train your own model. Means do some hyperparameter training, find some material, source material online for hyperparameter tuning and that stuff. Train your own model and means give a pull request in this repository like DSC NIT Surat reservoir. So give a pull request, and what I will do is I will uh, means utilize the best model. Whatever the model that is giving the best accuracy, I will utilize it for tomorrow's session for deploying it using Flask. Okay, so this is a task for you for tomorrow, and also I will be uploading this code today midnight 12. So before that, if you want to code it by yourself, then you can code it yourself, or if you want to just reference my code and utilize it for yours, then you can do it. So I will be uploading this code on this Meet Soni my repository, COVID detection from X-ray. I will be posting the link in comment section. Okay, so let me just post the let's try. Okay, sorry. Okay, so I will just post it. No worry. And also I will be posting this reservoir link. You just give me the pull request and I will check your model. Okay, so yeah, that's it. If you're in doubt, you can ask in the comment section. Okay, so no doubt. Okay, so let me just conclude the session. If you are in doubt, then you can also again ask in tomorrow's session. Tomorrow we will be means deploying using Flask. Before that, I will also take some doubt session like 5 to 10, 5 minutes like that. So you can ask, you can revise all the concept, and who have not watched this session live, so they can just revisit this session and see if they have any doubt. So you can ask doubts in tomorrow's session as well, before the session starts. Okay. So yeah, let's just conclude this session. Thank you everyone. Thank you everyone for coming.